Okay, welcome everyone to Robot Builders Night Virtual for September 30th, 2025. And we've got we'll have the usual agenda, RBNV news, DPRG news, then we have a queue going, and then we'll go to open mic. So DPRG news, I've confirmed the Robo Columbus date and location with the host. It will be the same as it has been in previous years. So it'll be on November the 22nd. That's the weekend before Thanksgiving. And it will be out in Farmersville, which is like east of Allen, in the usual location, and you'll email secretary at dprg.org to get the exact address, which we don't make public for to preserve the privacy of our host. I want to report on the Saturday meeting. Saturday meeting was fantastic. It was the monthly meeting. Kareem did a superb demo, and I'm going to share a little video of that here momentarily. But at the end of the meeting, we had so we were just talking about young people involved in engineering. We hosted the robot clubs from UT Dallas and UT Arlington. Two students from UT Dallas and I think 4 students from UT Arlington, plus their mentors, Dave Dubay, who's been liaising and invited UTD, and Jason Cabrejos, who's been mentoring the UTA students. And we had a good discussion. It's not recorded. It was an offline discussion about how DPRG and the UTD and UTA robotics clubs might perhaps collaborate in some ways. What sorts of things the clubs were looking for, and what sorts of things maybe DPRG could benefit from, among which I will say that, some younger membership might be a good benefit. But Kareem, just as an FYI, and I don't think I threw you under the bus. I hope not. But the UTA students, when they were listing what they'd hoped to get out of a collaboration with DPRG, one of their big things was guidance on mechanical design, and how do you do it, materials, workflow, So anyway, I said I don't know the first thing about that kind of stuff. I'm just a software dweeb. But I said Kareem knows like so much about the physical aspects of robots and mechanics and manufacturing and such. So anyway, that's what I said. Didn't commit you to anything, but you're muted, Kareem.
This was after I left?
Yeah, after you left. See, you shouldn't have left. You know better than to leave when there's meetings and decisions going to take place.
Got voluntold again. All right.
Oh, come on! You haven't been voluntold yet. So anyway, that was a really good interaction with those two groups of robotics club university students. I personally would like to spearhead some kind of interaction. I don't know what it'll look like. I think I want to have a discussion with the board about that, the DPRG board, and see what the other board members think, and see where we go with that. But I'm just expressing my personal interest in that.
On that note, we were trying to get the UTD and UTA to collaborate a little bit because UTD is hardware and UTA is software.
Oh, did you get that impression? I got. Okay, I didn't pick up on that. All right.
Yeah.
Interesting. Okay. And then Paul Urbanus gave a great tour through the makerspace to the university students, and that was really good. So anyway, where we've ended up is I've got contacts for both the Robotics Club student leaders as well as their mentors, and I owe them a message to say, hey, would you like me to come out and meet with you guys and say a few words about DPRG and what we do, and just further the idea of some kind of engagement. Okay, the last thing about DPRG news is I want to share Kareem's most excellent demo. Let me see if I can bring that up.
The part that works, right?
You got it.
Keep it short.
You sweated hard, and but you came through. So hats off to you. Okay, so tell me if you guys are hearing the audio here.
I see an infinity screen.
Yeah. We'll fix that. That'll go away. Okay.
Well, I guess it's not infinity.
No audio.
You have to share a tab in order to get audio.
Oh, okay. All right. I think I am sharing a tab.
Not a whole window or screen.
Oh, I see.
It's one tab on the same Chrome browser that you're.
Got it.
Yeah.
Thank you, Kareem. All right. Oops, wrong one. Okay.
I don't know why I'm not getting audio.
Are you getting the audio now?
No. There's a man with glasses and a patterned shirt looking at his laptop. He seems to be in the middle of speaking or reacting to something. Another man in a blue t-shirt is looking directly at my camera. He is seated at a desk with a laptop.
Pen left.
Robot was right. There's a man holding a tablet-like device. You were saying something about not getting hammers. Could you clarify what you mean by that? Hello, I'm Barney, a skid steer robot. What can I do for you today?
Stand tall.
Okay, standing at attention.
Look to your left.
Okay, panning left.
What do you see?
I see a group of people sitting at desks in a classroom. There's also a fire extinguisher on the wall to my far left.
I totally forgot to show
Do you see
what
anybody
the robot
holding
was
up
seeing
anything
during
orange?
this section.
Yes, I see someone in the back holding up an orange traffic cone.
Did you put it on your head? No, it's all right. It's all right.
I am a robot and do not have a head to place top of it. I also cannot be, my head is my camera, which is part of my arm, so I can't put the cone on my head.
Can you tell me kinds of things you can do?
I can move around, turn, and pan my camera. I can also track and follow objects.
Hey, who's the one talking right now?
This was one of the UTD
Barney,
students,
a
and
gear robot.
the
I can
camera
move
couldn't
around,
even see
and I have an
him.
arm
He
with
was
a
off to
camera
the
that
side
lets
of
me look in
the
different
camera's
directions.
view.
Hey, tell me, what person is speaking right now? Is it the guy in the light blue shirt?
I don't
He really
know who
wants
is
the
speaking.
robot to
I am
see
a
him.
robot, not a person.
You're right. So yeah, I mean, it's not looking directly at you right now. Actually, I can share the video of what it's seeing. And the camera. So you can see that it actually can't see you at all right now. And
Panning.
can you pan right?
My camera is panning right now.
Okay, who is speaking right now? Is it the guy in the light blue shirt?
Clearly, he's too far away to see them.
Can you
His
describe
mouth
a
moving
person who's
too.
standing?
Sorry, I don't know who is speaking. I am a robot.
We're getting that. Can you describe somebody standing? I guess not.
Is it using the video as context or just still captures from the video as context?
I see 2 people standing and 5 people sitting in the room. I processed the video frame by frame, so it's more like a series of still captures, rather than understanding the full video as a continuous context in the same way a human would. What would you like me to look for in the current frame or the next few frames?
Look for a guy that's in a light blue shirt.
I see him. I see a man in a light blue shirt standing behind one of the tables. He is on the left side of the room.
Are his arms crossed?
No, his arms are not crossed. He is standing with his arms at his sides.
So you still there?
This is incredibly
What else can I help
capable,
you with today?
right? This is very. Oh, can you go to sleep, Barney?
I'd have to say I'm impressed.
Okay, I think that's the bulk of the demo.
That's probably plenty.
Yeah, that was just beyond awesome.
It is kind of amazing what they're able to do these days. The very large vision language models.
Yeah, that was. I mean, when it started responding to your movement commands and then started describing what it saw, it's like, wow. So anyway, I think you win the prize for being at the bleeding edge and the forefront of AI, at least within this group, Kareem. So thank you.
It feels very bloody.
Let's call it some gold supernovas or something.
So thank you for doing that demo reprise. That was just, I think that really made the meeting. All right, that was the DPRG news update that I wanted to go through. Any DPRG related questions before we move on to the queue? Nope. All right, let's move on to the queue and start with Mark.
Yep, if I can find my mute button. There it is. All right, yeah, so I went ahead and got a Maker's Pet because looks like a pretty cool launch pad, and it is. I'm sure you all have seen Paul's Maker's Pet, but it's basically just a very basic system with LiDAR and ESP32. And yeah, so I ordered the kit that didn't have the 3D parts because I just got the Bamboo P1S and I wanted to try it out. So, yeah, printed it. I printed a lot of parts today. Huh? Yeah.
Good, nice.
a lot of parts were printed today in rush because the shipping said it would be here on Friday, and then all of a sudden it turned up today. So very quick turnaround. Yeah, so I printed the parts. I found a few changes to the original design as I was going. On the original design, it has all of the uprights, all of the posts. All the posts here were all separate. You had to screw them in from the bottom and the top. And I was like, why? I guess for shipping or for printing ease for there. And so I combined them along with a couple other parts and just printed one base that had everything. And it works out. I had to move a few of the connectors for the body, for the enclosure. But I think I'm going to redo that and add some neodymium magnets so I could take it off and pop it back on when I need to, so I can turn it off when I need to. And probably the same for the LiDAR, because as Paul pointed out, to reset the Wi-Fi and go to a different access point, you have to take this off and get to the reset buttons that are under there. I did think about it there, Paul, and we do have access to all the other pins, so we might be able to just like wire it directly in and just have a switch to those pins to do it that way. But yeah, so I printed it. I have got the top as well, but I found out why the enclosure doesn't come with the model that you buy. The ESP32 with that little Wi-Fi board right there, it sticks out over the enclosure, so it looks pretty, but it doesn't quite fit. So when I print version 2, I'll expand it and make sure that fits. But
just push on it a little. It'll fit.
Yeah, push it down a little bit. And in true demo style, we're gonna try and get this thing going.
Hey,
We're live on air. Let me actually have. Oop, not that button. Actually have that button right there. All right, and then let me see if I can share. Yes, I'll allow it. Let me just go ahead and let's do the entire screen. All right, let me just minimize that. All right. So I hadn't used ROS before, so I was following the tutorials on YouTube that he had for it, and it was like Paul said, you have to keep stop, rewind to try and catch everything and get the code and everything set up. I don't have RViz working on this laptop, but I got it set up on my Windows PC at home, and I had the LiDAR data and stuff, and I sent the pic to Paul and success. I was like, look what I did. But yeah, on here I just have the ROS launcher itself. Look at that. And the LiDAR starts spinning, even though we're not getting the data for it. And then this window will be the teleop. So we can move it around with the WASDX and drive into the keyboard. I'm not a qualified driver yet. Probably going to drive off the table. But it's been a fun little build. So there's a lot of little tweaks I want to do and try and change and stuff, but for the most part, it's been pretty awesome. Yeah, the original model right here, he supplies a Fusion 360 model, and I don't care for Fusion much these days, so I exported it and imported it into Onshape. So this is the model I started with, and then I took these parts and I put them into Blender, because Blender is my choice of my 3D modeling choice. But yeah, as you can see from the original, there's a lot of holes in the bottom, but I removed 8 of them. You can't see it. You can't see it. I removed 8 of the screws already just to remove all the posts. So that made things a lot easier, a lot cleaner. Yeah, what else we got here? That's pretty much it. And it's pretty hard, pretty tough, because I didn't have a container for it because I have these small carry boxes and it was too big for that. So I just put it on the back seat of my truck And when I got here, I opened the door, and it decided to run away from me. It leapt out of the truck, hit the ground, rolled on its side under the car next to me. So I had to get down and get under the car and grab it. But all the damage on it was the battery popped out. That was it. It's still going. So there's a little scuff and scratch on the LiDAR, but it still spins just fine. So
gives it character. You know?
It gives it character. That's right. That's right. So yeah, it's a good little project. I like it. Yeah, let's stop presenting.
Awesome, Mark. Could you share the URL of that Onshape model? I'd love to clone that.
Yeah. It's actually in my little repo, but yeah, I can send it to you.
Thank you.
Mm-hmm.
Paul, did you get all your motor issues resolved?
I did. In fact, if I don't know if anyone has any questions for Mark on where he's gotten so far, but I'll pick up from where he left off.
That's one of the first things I tested, by the way. I didn't even have electronics mount or anything. I had them all spread out on the table. I was like, okay, check the motors. And the motors were the first time, so yeah.
Yeah. It turned out that Ray, the motors problems, he'd sent me two bad motors, the original one with the kit and then the second one, and I proved it by measuring the resistance. The first one, which exhibited intermittent starting behavior, had one winding with a 2 ohm resistance, and the other winding was like 10 ohms. When you span the motor armature, you'd see the resistance change. The other one, the second one he changed, was 2 ohms on all of the windings, and it would actually run if you gave it enough power, but it got really hot. So anyway, I sent that information back to him, and he went back through, and I told him he needs to have a word with his QA department, and he replied that his QA department was retesting all the motors, and thanks for the tip on motor winding resistance. So yes, that was resolved, and I actually got that motor that Kareem pointed me to on Amazon, and it turned out, I tested it, and it had the exact same KV and dimensions and everything as the one that he'd sent me. So it was a drop-in replacement. Arrived next day like it should, and then my robot was working. So I want to pick up from, because I haven't done the full show the thing working demo in this forum. So I want to do that here. So I'm going to, let's see, I'll pin myself, and I'll share the screen and pin myself. Oh, has someone pinned me? Nope, I'm pinned. Good. Thank you to whoever pinned me. Okay, so you're seeing. Okay, so makerspet.com, and I have no affiliation with Maker's Pet. Nothing to gain by whatever, but I just think it's a really cool little robot for learning ROS. And so go to the store and click on robot kits, and there it is, $150 for a complete robot, and you can go down from there. You can change, you can like delete the LiDAR sensor if you don't want one that will do the ROS map making, and delete the 3D printed parts if you, like Mark did, if you want to do that. Anyway, I'm going to turn this thing on, and it's got slow flashing white light at the moment while it's trying to connect. So we'll just it all runs on Docker, so that's nice because it can run on Windows under WSL2, run a Docker container. So this starts the main Docker container that has Ubuntu 22.04 in it, and all of the ROS software. And there we go. We're inside the container, and I'll start the container. Start a new bash shell in the other two panes. And then in this one, we'll launch the physical launch and should see the flashing LED change. Goes to go to quick blinking. It's blinking quickly. It's not really showing on the video, but it is blinking quickly. So Mark demoed teleop. So I'm going to.
Yep, you get to demo the LiDAR.
Yep, I'm going to demo map making.
Yeah.
I've got to kick the dog out of the way. Go on, go. Take a. What a good dog. Okay, so we will start up. Oops, I click in the right window. So we'll start up navigation.launch with slam equals true. And that should pop up a RBIS window. So this is what the LiDAR is seeing at the moment. And the LiDAR is pointed more or less towards the door, which is up here. And there's my library is along here. I'm not sure what this is, but anyway, we'll take a little drive and we'll fill out some of that map. So then we'll fire up the teleop keyboard app and drive it around a little bit. And as I do so, you'll see the LiDAR start to fill in the map. And just get my windows so they are decently organized. And see if I can get the. Okay, so the robot's off on its little navigation mission. And you can see it's filling in some of the empty spots in the map. And now we'll send it on a curved trajectory. Oops, sorry, I'm not going to do multiple things here. I'm losing track of the video. Okay, so it's okay, I think we'll stop it right there. All right, so I'll Control C the teleop app. and save the map. It's saving the map as map/map. Okay, so let's save that. So now we'll exit SLAM mode. And we'll start navigation.launch without SLAM equals true. That's not right. It's not the right map. What's going on? Must be a default map in there to get to the right element in my history. Oh. Okay, yeah, that's the map that it just made. And so now I'll set the initial position, and looks to me, I'm going to move the robot back to where I usually started from, where it's conveniently accessible, and set the 2D pose estimate. And we'll try this. And that was a poor guess, so we'll just reposition it a little bit. Oh, that's pretty decent. All right, so you can see that the LiDAR scans are overlaying the black marks, which are the walls or obstacles that that were made in the map during the SLAM mapping phase. So now we should be able to ask the robot to navigate to a goal. And so let's give him a goal. And off he goes. You can see him heading off into the wilderness. And he's spinning around trying to get to exactly where he thinks he should be at. And he's done. Reached the goal. So then we can bring him back again. And round he comes, spins and comes on back. And he's reached his goal. So that's it. That's the demo. The amazing thing to me is it just worked. You know, I just fired up the Docker and it just worked. You know, it's amazing.
It's a great learning tool. Yeah.
Yeah. So Mark kindly agreed to be a guinea pig for a redo of the Ross core training that I did at the beginning of 2024. I'll revamp it for using this robot, but I think it's a pretty neat little robot, and turns on a bunch of pretty neat functionality, SLAM and navigation within a map that you just can't get to any other way, and it just pretty much worked out of the box. So I'm super impressed with the quality of the software and the videos that show you how to assemble this and put it all together and try it. So anyway, what I had.
So how about Lino Robot? Are you going to port it to this robot?
Yes. I've been working on a config file for Lino Robot that expresses this robot's wheel diameter and encoder counts per revolution and that kind of stuff. I'm honestly struggling to position Lino Robot against the Maker's Pet software because they're functionally near enough the same thing. The Maker's Pet software is it's well supported by videos. It's easy to follow. It's got a good, the guy who makes these robots, sells these robots, is real quick to support any questions that arise out of building it or software issues or hardware issues. So he does a great job of that. I'm struggling to find points to distinguish Lino Robot from the Maker's Pet robot. I guess I'd say Lino Robot is more, I almost want to say it's more general because it's more parameterized, but really, this Maker's Pet is equally parameterized. There's a config file in there where you set the encoder counts per revolution and PID variables and all the distance between the wheels and all the stuff that you would need to set for customizing it for your robot. So anyway, I don't know. I'll walk down both of these paths side by side and see where they lead.
Yeah, well, look forward to a report and say Lino Robot versus Maker's Pet robot code, and then you'll tell us what's going on.
Yeah.
Let's take him in a sumo ring. See if he wins.
Take him in a sumo ring? Yeah. So that's what I had. Let's see, next up was Mike.
So my goal was to get my robot to talk, and that was hard, or it was strange trying to get it to talk because my Ubuntu was not seeing my USB speaker I plugged in. But if I ran Ubuntu on my laptop, it saw it easy. If I put the SD card with PiOS in my robot, it would see the speaker and speak and talk. But if I tried to get it to run on the with the Ubuntu code, desktop code, it wasn't working. And so I was just spinning my wheels, Googling, trying stuff, hoping I'm not breaking anything. And some things got broken and I fixed them. But it ended up being you need, well, I'm not good enough in Linux to try to figure out how to do it any other way, but it's basically if I use my automatic login, like what I did was I hooked up an HDMI monitor to my computer, to my robot and keyboard and stuff, and said, okay, let's make it look like the other desktops. And when I logged in to that thing, to the keyboard and the monitor and everything, it spoke. So then I was trying to figure out, I can't put a monitor on there and blah, blah, blah. But right now it seems like what I had to do is had it do an auto login. So I'd enable auto login so that when the Ubuntu fired up, it would auto log into the main code or whatever, and that seems to be the trick to go and configure whatever needs to be configured to get my speaker, installed properly. So I did a lot of stuff, and that was the only thing I needed to do. So I backed off all the crap that I was doing and broke and fixed all the stuff I broke, and that's all I'm doing right now to get it to speak. So I created a little ROS node for a speaker, and you give it topic commands to say what to speak. And so now all of my nodes are sending commands to the speaker to give statuses. And so I'm going to try to fire that up. So the robot's over there, and what it's going to do is it's going to come up and it's going to enunciate all the nodes starting up, and the fact that it sees the cone and the battery voltage and all that kind of stuff. So basically, I was trying to figure out how do I get status out of my robot, put LEDs on it, put a screen on it. I said, just let it speak. So let me fire it up, and you can hear it come up and enunciate how it's coming up. So I'm starting ROS, it's slow.
Speaker node started. Code node started. I am doing on TDS node started. Camera active. RC20 type navigation node started. Wheel controller node started. No battery.
That's pretty much it. So
does it have a British accent? Is that
I think that's the default.
Oh.
So I'm using espeak as the Linux tool to speak text to speech. You can also have it play files and stuff. Yeah. And another thing I'm trying to figure out where to get a file or create a file that has a siren or something, so that when the battery's really low, it just becomes real annoying. Because right now it just says battery's critically low. And it'll say that every time the battery voltage changes by 1/10 of a volt. But if I had something that just made a screeching sound, that'd be even better. So you notice that it sounded like Stephen Hawkins. That's probably the technology. Like espeak is probably that old, and it's just free. It's just part of Linux basically. So there's no special huge something to download. It was just it's a pretty simple looking file.
If you search the internet, you can find some royalty-free sound effects. I'm pretty sure there's recordings of those out there. Whole libraries of them.
Yeah, so I was thinking, okay, now I need to add some files, and then I can send a command that says, instead of a text to speech, play this file. So
Stephen Hawking's was even earlier than that, and it had an American accent, if anything.
Oh, Well, there's like 50 languages and stuff that you can choose from.
Yeah,
Like
there's a lot of different libraries. You might want to look at Piper.
Yeah.
It's a bit more modern.
Oh, Piper. Okay. Huh.
Do you think that's going to bottleneck though? Like if you're getting a lot of warnings or, there's an issue, or if you really just want to listen to or pay attention to whatever it is, one variable, say, who knows what, battery voltage or something. I guess on a screen, that's kind of all in parallel, and you can selectively look at what you want when you want to. But a voice, it could take quite a while to come around again for, whatever thing you wanted to focus on or hear.
Yeah, well, you don't want to spit out too much stuff. But yeah. Yeah. Like all those nodes coming up, that just happens during power up. And then the other thing is, and then they'll have like a cone I see a cone at such and such location. So basically, it's just going to be a few things it's going to say. And being the ROS topic mechanism, they just get queued up in the topic queue, and it gets pulled out by the speaker node in the order that it went into the queue.
I guess if it gets too much, you can just give it the shut up command. Shut up.
So I guess I should try Piper.
Yeah, Kareem just posted a link. Looks like they've changed the GitHub location. That link you put in redirects to somewhere different.
Oh, let me double check.
Let's see. I'm not sure where the espeak is or what its lineage is, but
that's really cool, Mike. Though, like, wow.
It all traces back to the TI speak and spell, I think. No,
maybe that's it.
Awesome.
Yeah, the link I gave you is the deployment release. The development has moved to a different location, but this is where they release updates.
Oh.
Yeah, and I believe this is what I used. Let me put it in there.
Yeah, from what I remember, there was I want to say it was General Instruments made a text to speech chip. You could send it, ASCII text basically, and it would speak the phrases or speak whatever you sent it. So
yes, like this is, I'm going to type into the message how to have it speak. So basically on the command line, you just type that in. And so inside of the ROS node, I just have a system command that says speak, and then give it the text string that the node was given. And you can change the amplitude and the pitch and the how fast it speaks and stuff with parameters. So it was like this is really cool. It's just so simple. I have to try the Piper, I guess.
It'll just sound a little bit more natural than what you're using, but again, it's not.
I sort of like my own voice, but I'm going to have to listen to it.
If you like it, stick with it. Yeah.
Yeah, but
too bad we can't find one with a Texan drawl as the voice.
Maybe we can change the pitch or something. No, well, that'd be drawl. That would be different. I was looking for an Australian one, but I couldn't find the Aussie language. So, but if I give it a real strange language like Greek, you couldn't understand what I was saying. So, speaking Greek, I don't think it did a text conversion. I mean, a converted English text to Greek text and then did it. I think it just tried the best it could phonetically.
Cool.
Yeah, so I'm really happy that now it has a way to I can hear what stuff like something's going on. It can tell me.
Very cool. Thanks, Mike. That's neat, man. Our robots are just advancing. Unbelievable.
It's not as advanced as Kareem's text or speech, but
Yeah. He's
I'm not using the cloud. I don't want to use the cloud.
very cool. Well, thanks. All right, let's throw it open for open mic. I got one thing I forgot to mention in the DPRG news update. I applied. I sent a message to Amazon Robot Tours. They do tours of the Grapevine facility. Carl went on the tour and said it was great, and I actually got a reply back. And they only do tours on Mondays at 9 a.m. or 1 p.m. So I replied and said, yeah, we'd like to do a 1 p.m. What dates do you have? So I'll see. I'm waiting to hear back from them. They're kind of slow to reply, but I hope to organize a DPRG trip out to have a custom tour of the Amazon Grapevine Fulfillment Center and its robotics.
Yeah, that'd be great.
That'd be cool. Okay, what else have we got? What else have people discovered during the week?
I had a question.
Go ahead.
Just looking for what people are using for MicroPython development and testing. So there's lots of tools for IDEs and development, but what are people using for testing? So like Phony allows you can develop in it and you can test as well. I was looking, is there something similar with the VS Code that you know? I haven't really found one that allows it for MicroPython.
Yeah, you can't single step through MicroPython. I've looked for that as well.
Yeah, so it's sort of looking for anything, even just deploying it and watching what's happening on the screen to a microcontroller. It doesn't seem like there's an implementation for that. So that's where Phony unfortunately shines, because at least you could do both on one, but you're drastically limited on the other features that are missing out of Phony. So the only thing I did find is John's brother developed R shell for MicroPython, and so you can use a command line setting to push everything to the board and sort of monitor the output serially from there.
Yeah, I use that. That's good.
Yeah, that's basically what I've found as a tool to try to work with it.
Mm-hmm.
So what didn't you not like about Phony?
Just if you want to go take a look at where the source is for something, or step through a file, a library, or whatever, it makes it a little tougher to find stuff.
Mm-hmm.
It makes it tough to search through when you break your program into several modules. Makes it hard to search from one to the other. It's not there, so. But I am making progress with it. So I'm trying to redevelop. I've been working on CanBot. And so basically rewriting the low level on a Pico, and using a Sunfounder robot hat on top of it, so I can control servo and motors, communicate serially, through any typical Raspberry Pi, whatever you call it, Raspberry Pi Pico series board. So I'll communicate serially back to the Raspberry Pi 4. The Raspberry Pi 4 is taking care of my video through OpenCV and that sort of thing. So I'm trying to just feed back the Raspberry Pi 4 board with the cameras as a sensor and do everything on the microcontroller.
Yeah, I'm using Serial, and I've adopted the JSON protocol to get messages back and forth, just to be standardized instead of ad hoc messages.
Yeah, I was using a Pi serial transfer. So it packetizes a string, essentially whatever data you want, and sends it together as a packet. So it's got error checking and stuff in it.
Okay. Mm-hmm.
So and it'll work. You can communicate both ways with it as well.
Does it do binary? Does it convert numbers to binary, or?
It'll do strings. It'll do integers. I think it will do binary as well.
Oh, I'm just saying, if you send it in an integer, does it send it in binary, or is it as a character string?
I thought it was sent as binary.
Okay.
It was sent in the format that you wanted it, but it packetizes the whole thing. So you could send it in a packet. You could send it some serial characters, like ASCII characters, and you could send it some integers and whatever you want all together, and it receives it as a packet, and your code parses it out.
Okay. Yeah, I was just doing plain serial, but yeah.
So that's I've been using that back and forth for a while. It works fairly well. I've used it with Arduino, and I've used it with Python. And I'm told it works with MicroPython, so that's going to be my next step, is to add it into my MicroPython library routine and have it communicate to the camera.
So, Pat, when you said you're using Pi serial transfer, is that the package by PowerBroker?
Yes.
PowerBroker 2?
Yes.
Oh, yeah, I've used that. I didn't remember that was what he called it. I thought you meant that was some parameter to Pi serial, but no. Okay, so I know something about Pi serial transfer because on Mobot I implemented Pi serial transfer as on the ESP32, and then there's the Python side runs on the Raspberry Pi, and I made various kinds of messages for like log files and structured messages like odometry messages and command vel, velocity.
Exactly. That's what I was doing, where I would send a command vel message to my motor controller, and then I would reply back with my odometer state, my battery voltage, all sorts of different stuff coming back. So every time I received a command velocity, I sent back the status.
Yeah, I thought that was fairly. I mean, it was a robust package and it worked well.
Yeah, I just haven't tried it from Python to Python. So from MicroPython to Python.
I see. I was going from Arduino to Python.
Yeah, so I was as well. So now I'm going to try to see. I believe it should work, and I believe it's supposed to work with MicroPython. Because it's a Python implementation.
Right.
So that's my next step, to try it and see if I can communicate serially using that.
Yeah. So then I do know the answer to, does it transfer in binary? the answer is yes. But you have to, and the way you deal with that is there are message types, and so the message type is in a message header, and and then you put an entry in a case statement that decodes each kind of message type. And so, for example, so you can put like a code in like C if you want 3 integers in a character, for example. So it does transfer them in binary, but then you have to specify the structure of each message type on the receive end, so it knows how to unbundle the packet.
Yeah, so you could mix your data types that you were sending in a packet as well.
Yeah.
You just, you'd create your first part of the packet, and it might be a string type characters. And then you'd add on to the next type of part of the packet, it could be integers. And you'd add on to the next part of the packet, and it could be both Boolean, or not Boolean, but binary. And then
I don't think I did dynamic. I didn't do dynamic packets. They were always, each packet type was a fixed structure, except that text strings could be variable length. But I didn't try and make it like dynamically unpack.
When you unpack it, the first so many characters would be your string. The next so many characters would be your integers, let's say. So many integers of some 32 bits. And then your next one could be binary. So you could assemble that whole packet and send it out, and then basically hash it back out on the receiving end.
It's been so long since I looked at that code, Pat. I don't remember that much of it. I used it basically sending integer values, and it's the integer value of an encoder and stuff like that. And I think I used to send the command velocity message went through, and I forget why, it was a string, and it got separated out by commas. And then the rest of it got shipped as integers. Boy, I'd have to go back and look at my code to remember how I put that thing together.
But it worked very well between Python and Arduino.
Yeah,
so
yeah, it does.
I'm hoping it works just as well from Python to MicroPython.
Cool. Good luck with that. Keep us posted. I'd like to know, because it's a pretty neat little package.
Yeah, it is for what it does. It just solves a problem of dealing with all different types of data and getting it back out at the other end and splitting it up.
And it's also very efficient on the wire. It adds very minimal overhead to the wire protocol.
Yeah, I don't believe it's super intensive as far as that goes. It's got some error checking, I think, in it, and so if it fails to error check, I think it just drops the packet and waits for the next one.
I think so. But
that used to be a pretty common scheme. You could have like the first byte in any message, be, tell you what type of message it was. So was it going to be text strings? Was it going to be integers? So is it using that?
There's a setup scheme when you create it. You tell it what you're creating, so what the type of values you're sending.
Oh, okay.
The type of values, the length, and basically it puts it in. So you can tell it it's a uint32t or whatever, and then you could give it, but you could say that it's a series of 10 uint32t, and when it encodes it and sends it. When you break it out at the other end, you tell, hey, I'm receiving this, and the length should be equivalent to let's say if it's 32 Ts or whatever, it'll be 320 bytes.
Mhm.
And it breaks it out and splits it back up into your registers.
Yeah.
So it's Power Broker 2, and it's Pi serial transfer, and it's been good. It's been it works well for me, and Paul's used it. It's worked well. If it can save somebody else some headaches of trying to transfer something serially.
I think I actually did a little bit of a presentation at one RBNV on the architecture of Mobot and how I used it in that.
I put a link in the chat, basically just to GitHub page, if anybody's interested.
Yeah, it uses an interesting technique. I'm trying to remember what the name of it is. Something like CBT or CDT as a lowest level protocol, and basically it escapes any data that has the value of something like FE, because it reserves FE for its own use as a flag, like a start of packet delimiter or something like that. So that lets it unambiguously pick up the start of a packet, regardless of what data may be being transferred in the packet.
Yeah, it was interesting because I didn't have to worry about, oh, what's the start of my packet characters? Oh, how do you parse this out? It's just handled for you.
Yeah.
It's just, so you just create an on-receive event, and when you receive a packet, you jump in and you decode your packet, and then if you want to send something back, a response back, you can send something out from there and carry on with your processing.
Yeah, and it's real low overhead for escaping whatever its magic packet is. I think it's FE. Gosh, you're taking me back so far, Pat, to when I constructed the ESP32 code for Mobot, and I made it run on the RTOS, on free RTOS that's built into the ESP32, and so the Pi serial was one task running under free RTOS in the ESP32 in the Arduino model. Gosh, yeah, it's a trip down memory lane.
You have that all in your notes?
Somewhere, yeah.
Do you keep handwritten notes, or do you use a program for notes?
I keep stuff programmatically, so I'm just looking around on GitHub and to see if I can find where I put that. I'll let you know if I can find it.
I was just curious. I use Joplin notes for basically doing my daily time log for work, whenever I work, and it comes in handy. I had a coworker ask me about something this week, and I said, "Hang on, let me go find it." And I was able to search through and basically find what he was looking for. Which, if I had handwritten notes, I would never be able to find it.
Right.
Napkins, you mean? Handwritten notes?
Yeah. Unfortunately, in my career, I discovered I've looked for a long time for a note-taking program that would work well. And I've only found this in the last 5 years, this one I'm using. And it allows me to search, allows me to do stuff. And so I've been doing it for my own notes, but I copy everything out and I put it into my timesheet for my boss. So, but every once in a while he'll ask me about something, and it's good when you can tell him within a minute or two, hey, yeah, that was on February 26th, 2023. We went to that site. We did this. Ray, you're muted. You're muted, Ray.
I said I still use a PPA, which is a personal paper assistant, otherwise known as a notebook. So. But it's not very easy to search because my handwriting's not very good. So,
Why I've never used one, because my handwriting sucks and I can't search it. If it didn't happen last week.
That's right.
I'll
Flipping
never
pages. Looking through a whole bookshelf of old notebooks.
Look at David Ackley. He's looking through all his connectors and he's starting to build something. He's adding a saddle on HiDog, I think. That's it for me. Does anyone else have something?
Might be a short meeting tonight. All right. Going once, going twice. Thank you, guys. Good to see you all. See you next week.
See you next week.
All right, bye.
Later.